Okay, we're going to finish out the notes in this video, so we are on page 8. We're going to talk about ways to prove that a quadrilateral is a parallelogram. This is going to look really similar to what we already did in the last section. In the last section, I told you it was a parallelogram and you had to use properties of parallelograms to solve for variables. This time you're going to solve for variables so that it would make a quadrilateral parallelogram, but you're basically going to use the same properties that we did in the last section. Okay, so you'll notice I have 4 ways to prove that a quadrilateral is a parallelogram. There's actually a 5th secret way that I always forget to include in the notes. We'll write it off to the side. So the first one is to show that the opposite sides are congruent. So that would look like this. If you can show that that is true, then it has to be a parallelogram. The second way is to show that the opposite angles are congruent. So this has to be both pairs of opposite sides are congruent, and this one would have to be both pairs of opposite angles are congruent. You need to show all that. Okay, the third way is to show that the diagonals bisect each other. Okay, so if I draw that in, draw in the diagonals, you need to show that piece and these pieces are the same. Okay, so the last one is not the last property that we learned, that the consecutive angles are supplementary. That is kind of a part of this one. If you can show the consecutive angles are supplementary, you can probably already also show that the opposite angles are congruent. So it's usually easier to show this. This one is the one you're going to forget when I tell you to name all the ways to prove that a quadrilateral is a parallelogram. This one you show that one set of sides is congruent and parallel. Okay, so this isn't any of the properties that we learned in the last videos. This one says I'm going to use the top and the bottom, but it could be the left and the right side. So one set of sides is congruent, so I'm going to put the sign to show they're congruent, and parallel. So you can show they have the same slope and they're the same length. That would be fine. So the 5th way I'm going to put over here, the 5th secret way, is to show that the definition of a parallelogram says that opposite sides are parallel. So that looks like this. I'm drawing a parallelogram. Show that these are parallel. Show that these are parallel, and it would have to be a parallelogram. Okay, so that you might do that with slopes. Actually, that's the only way that we've talked about how to find things are parallel. So let's go to page 9. So in quadrilateral ABCD, AB and BC are the same, CD and AD are the same. Is it a parallelogram? So I'm going to draw in quadrilateral ABCD. I'm going to go ahead and make it look like a parallelogram. A, B, C, D. So AB and BC are the same. So AB and BC are the same. Okay, so I put the same marking on them. Those aren't opposite sides, so this isn't looking good. Then it says CD and AD are the same. So CD and AD are the same. So it's possible that it's a parallelogram if all 4 of them are the same length. They didn't tell us that though. So I'm going to put that there's not enough information. So our reason is going to be because consecutive sides are congruent, not opposite sides. So I'm going to put we need opposite sides congruent. Not consecutive sides or adjacent sides. Okay. It is on. No, it isn't. Let me turn that light on. It's a little easier to read. Okay. Now, this is a lot of what you're going to see. For what values of x and y is quadrilateral a parallelogram? So these are marked on the sides. So I know that if it's a parallelogram, then the opposite sides have to be congruent. So if the opposite sides are congruent, then it is a parallelogram. It's a property we just learned. So looking at the top and the bottom, I would have an x and a y in my equation. So that's not a good place to start. Looking at the left and the right, though, those both have an x. So we only have one variable to work with. That'll be much easier. So I have 24 minus x equals x plus 6. I would add x to both sides and get 24 equals 2x plus 6. Subtract 6, 18 equals 2x. Divide by 2, x is 9. Okay, so that's what x equals. So then, if I put the top and the bottom equal to each other, I know that x is 9. So that would become 2 times 9 plus 3 for this equals y. That's 18 plus 3. So y will be equal to 21. And those are our two answers. Okay. This is kind of a dark picture, but it's a doorway in a really old building in England. This is actually from your textbook. It's in color in your textbook. Over time, the building has been leaning sideways. Explain how you know angle S is congruent to angle U. So, really small in the picture, you can see there's a little arrow here and a congruent marking here that go up here. So they have marked the top of the door and the bottom of the door are still horizontal. Okay, can't even see mine marking there. And then the top of the door and the bottom of the door are the same length. So that means since the top and the bottom are congruent and parallel, it means the whole thing has to be a parallelogram. So we know that angle S is congruent to angle U because the opposite angles in a parallelogram are congruent. So I'm going to put ST and VU are congruent and parallel. 3 dots, I don't know if I've told you this before, is shorthand for therefore. Okay, so this means therefore ST UV is a parallelogram. And then I'm going to put that those two are congruent, so angle S is congruent to angle U because the opposite angles of a parallelogram are congruent. Okay, just take a moment to think of all the vocab we have learned this year. That this would look like nonsense to somebody who hasn't taken geometry yet. All these symbols in the middle of our sentence, but we've come a long way. Okay, so the last example, find for what value of x is the quadrilateral parallelogram. Well, I know that if I can prove, or if I can show that the diagonals are congruent, that it has to be a parallelogram. So we already have marked that Fn and Nd are congruent, so all we have left is to put the Cn and Ne congruent. So we have 4x minus 11 will be equal to 2x plus 17. Subtract 2x from both sides, add 11 to both sides, you'll get x equals 14.